Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Amili Razik. I am first presenter of this group. I would like to present about this assessment. So, content entitled for this project is introduction, analysis, calculation, and simulation. Then discussion, and lastly conclusion. For the introduction, we have 3 points. Firstly, in electrical engineering and electronic, the concept of the frequency response and bandwidth play an important role in understanding circuit behavior and performance. Next, the frequency response of a circuit is influenced by various components and parameters such as a resistor, capacitor, and inductor. Lastly, for the bandwidth, is directly related to the frequency response, is often defined using a specific criteria. Okay, for the question 1, determine RE and find a mid-band frequency voltage gain. AV equal to V out over V in. So for the IE, I have answer is 1.65 milliampere. Then for the RE, 15.76 ohm. And for the voltage gain is negative 90.1. Okay, next for the question 2, draw the low frequency AC equivalent circuit is for the first one. Then for the FLS, I get 6.86 Hz. For the FLC, I get a 25.67 Hz. For the FLS, I get a 3 to 6.8 Hz. Then for the RT, I have a 2.32 k ohm. For the RS, I get a 589 ohm. And for RT, I get 24.35 ohm. Okay, for the question 3, sketch the low frequency response using a board plot. So I get the graph like this.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Akul Asrah bin Muhammad Rasdi. My number metric is CE 220053, and I will present about question 4, the frequency equivalent, and find the FHI and FHO, and identify the height cut-off frequency of the system. At here, we got a frequency equivalent, and we found a FHI. FHI formula is 1 over 2 pi RTHI CI, and we got 695.9 kHz. And for FHO, the formula is same, but change the capacitor, only use CO. And we got for the higher frequency or cut-off frequency amplifier is 695.9 kHz. And this is a high frequency cut-off graph, and this combination sketch from the handwriting sketch for combination of cut-off low frequency response and high frequency response, and we combine it into a board plot. And this for the question 6, and get this graph. And also we got this graph in a simulation, but I don't show here, it's in the report. This I show here. This is for question 7. Sketch for the, I use multisim for get AC. I will forget the graph for low pass frequency and high frequency response. From the simulation, I run using multisim and get this nice butter plot. and this is a bandwidth calculation using the bandwidth from simulation. This is a bandwidth. We took the blue. The blue is for x axis, and at the high frequency it is FH, and for FL for the red line, and for the bandwidth, for we know the formula is FH minus FL. So here is the calculation about the calculation to find the bandwidth FL and FH. So the bandwidth is FH minus FL. So we got the bandwidth is 491.54 megahertz. This is a bandwidth. Thank you.
Assalamualaikum, my name is Muhammad Afiq bin Mokhtar, metric number CE220080. I will present about discussion of this group assignment. First is the voltage gain. For the manual analysis, we get the voltage gain of 90, and this value represents the amplification factor of the circuit for the specified frequency range. Next is the cut-off frequencies. The manual analysis yielded or show three cut-off frequencies, which is low frequency stop band (FLS), low frequency corner (FLC), and low frequency end band (FLE). All these frequencies range in the circuit's response starts to attenuate or roll off. Next is the high frequency cutoff. For the manual analysis, the high frequency cutoff or HFI of this circuit uh, show in which the response starts to attenuate significantly, and the value we get for this assignment is 995.9 kilohertz. And lastly is the bandwidth. The bandwidth is represent the range of the frequencies over which the circuit's response remains within a specified range, typically defined by a gain threshold, and the value we get in this assignment is 491.54 kilohertz. For a conclusion, the voltage gains in this circuit was 90. In this show the gain over the specified frequency range. And in this circuit there is three cut-off frequencies, which is low frequency stop band (FLS), low frequency corner (FLC), low frequency end band (FLE). All these frequencies determine the range over which the circuit's response begins to weaken or die out. Next is the high frequency cutoff or the HFI, and this frequency show the point where the response begins to weaken significantly. And for this assignment we get the high frequency is 995.9 kilohertz. And lastly, the bandwidth. The bandwidth we get for this circuit is 491.54 kilohertz, and this value represents the frequency range that the circuit response falls within a certain range, usually defined by a gain threshold. And in this analysis, we can get the voltage gain, cutoff frequency, high frequency, and bandwidth. All this information is important to be understand, so that we can know at which condition that this circuit suitable to be used for. And that's all from us. Thank you so much.